Welcome to the deep dive. Today, we're diving headfirst into the really dynamic world of large language models, LLMs, and how they're just rapidly reshaping technology. Our mission here is to really unpack the basics, the core concepts of pre-trained LLMs, and this thing called transfer learning. Then we'll zoom right in on how a platform, specifically Snowflake, turns these big ideas into, well, practical, real-world AI applications. We'll walk you through a detailed example involving image processing and automation.
Yeah, and what's so interesting here, especially if you're looking at AI in like an enterprise context, is how we connect those abstract ideas to, actually doing something. We're going to show you how these really powerful models become genuinely useful when you tailor them for specific jobs.
Okay, let's unpack this then. So starting right at the foundation, what exactly is a pre-trained LLM? My understanding is these are AI models already trained on just huge general data sets, books, articles, websites, that kind of stuff. So they learn these broad language patterns, almost like they have this vast general knowledge base. Is that about right?
That's spot on. The sources define it as an AI model trained in advance on massive amounts of text data to understand and generate human-like language.
Hmm.
And the real breakthrough, their ability to do things like summarizing, translating, answering questions without being trained from scratch for every single use case, that's a massive time and resource saver for businesses. Huge.
Right. And that leads us to where it gets really interesting, I think, transfer learning.
Yeah.
So you've got this LLM that knows a lot generally. Transfer learning is like taking that knowledge and applying it to a specific task, kind of like taking maybe a brilliant GP and giving them specialized surgical training. They build on what they know.
Perfect analogy.
Yeah.
And it really highlights the two-stage process, behind so much modern AI. First, pre-training gives that broad understanding, text, images, whatever.
Mhm.
Then transfer learning fine-tunes it for something specific. If you look at the big picture, this two-stage thing is absolutely key to why LLMs perform so well across so many different areas. Makes them scalable.
So how does a platform like Snowflake make these pre-trained models accessible? The source mentioned Snowflake Cortex. It sounds like Cortex lets you use pre-trained LLMs directly in SQL for like basic text predictions. Things like next word prediction on your phone keyboard. The example was select snowflake.cortex.complete, the product is, or even predicting motion in videos.
Exactly. And that's the beauty of it. For common tasks, summarization, sentiment checks, text completion cortex lets you do these powerful language tasks with simple SQL. You don't need external models, no complex setups. It just works. Which really brings up a key question, I think. How does this seamless in-database thing simplify AI adoption for organizations?
Yeah, that seems like a really crucial point because, I mean, traditionally getting AI to work with your data meant lots of moving parts, right? Integration headaches. If it's all happening inside the database, well, you skip all that data shuffling between your warehouse and some external AI service. It's all right where your data lives. That streamlines things massively, doesn't it?
Precisely. Less friction, faster insights. And that takes us nicely into the next big step, taking that general knowledge and making it super specific through fine-tuning. Our source lays out a really great step-by-step pipeline using Snowflake for a real-world example, processing images from security cameras.
Okay, so walk us through that. This Snowflake step-by-step pipeline for image processing. I gather Snowflake stores the metadata, but the actual images or videos are processed externally using Snowpark Python or APIs.
That's right. So step one, security cameras automatically upload files to cloud storage, think S3 or something similar. Easy enough. Step two, you prepare a metadata CSV file. This is key. It's just a simple file listing details for each image. A file ID, the path of the image in storage, timestamp location, maybe an event type, like the example. 1s3.security footage cam 1 image 0001.jpg 1000 2025 06 24t10.0000000 say entrance entry. Simple stuff. Step three, load that metadata CSV into a Snowflake table. Standard SQL, nothing fancy there. Okay, step four is where the more specialized stuff happens, often using a Snowpark Python script. Snowpark Python lets you run Python code right within Snowflake. So this script reads the metadata, grabs the image URLs, and sends them off to an external computer vision API. That API does the heavy lifting, face detection, object recognition, you name it. Then the results like what object was detected and the confidence level, say detected person confidence 0.98 gets stored back into Snowflake. And finally, step five, automation. This is powerful. Snowflake streams detect when new metadata rows arrive, and Snowflake tasks automatically trigger that Snowpark Python script to process them. maybe hourly or on whatever schedule you set.
Okay, got it. So images processed, insights extracted, all nicely stored back in Snowflake. But you said that's not the end game. This process data becomes the fuel for the next step, right? The fine-tuning part, making the model even smarter for our specific needs. How does that work?
Exactly. That process data is gold for teaching a model your specific context. So the next stage is dataset preparation. You basically transform those results, like person detected at entrance, into prompt and completion pairs. So the prompt might be, what object is detected in image 1? And the completion is person. You're structuring it for training. Then, dataset export. You export this prepared dataset, maybe as JSON, out to cloud storage again, ready for the next step, which is external model fine-tuning. Here, you can use Snowpark Python again, but this time to trigger the fine-tuning job with an external LLM provider, OpenAI, Anthropic, whoever you use via their APIs. After that, you've got model monitoring and inference. You track how well your newly fine-tuned model is doing, and then you start querying it for those really specific answer to vision tasks. And crucially, automation of retraining. This is key for keeping the model fresh. Snowflake tasks and streams can automate retraining your fine-tuned model whenever enough new data comes in, so it stays up to date.
Wow. Okay. So what does this whole pipeline mean for you, our listener, running a business? It sounds like it means taking these powerful general AI tools and really sharpening them to solve your specific problems. It's not just security footage, is it? You could use this for quality control, analyzing customer feedback, anything where you need specific insights from unstructured data like images or text tied right into your business data. It's about building precision AI tailored just for you.
Exactly. It's moving from general capability to specific, valuable application.
All right, let's maybe pull back a bit now and look at the bigger picture. LLMs, they didn't just pop up yesterday. The sources gave a pretty fascinating overview of how AI capabilities have evolved to get us here.
Oh yeah, it's been quite the journey. The source calls it vendor capability comparison across LLM evolution phases. It breaks it down nicely. If you go way back, early phases like 1950s to the 2000s, you had manual mining. Think rule-based chatbots like Eliza, no real learning. Then came hand tools mining, statistical NLP, but pretty poor context understanding. Next up, neural networks emergence, maybe 2000s to 2017. That was mechanized mining. We got word embeddings, early neural nets, better, but they struggled with long sentences, long-range dependencies. The big leap was the transformer breakthrough, 2017 to 2022. The industrial refinery phase, where transformers came in, pre-trained LLMs like BERT, GPT-2, GPT-3, much better context understanding, but computationally expensive. And that brings us to now the generative AI era, 2023 present, the global gold market phase, as the source calls it. Now we've got real-time LM APIs, models handling text, images, audio, multimodal stuff, fine-tuning is common, private deployments. And you see AI embedded in cloud platforms like Cortex. Of course, there are ongoing challenges too, guardrails, bias, hallucinations, privacy concerns. It's still evolving fast.
Okay, quite a journey. So with that whole history in mind, where does something like Snowflake Cortex fit into this current global gold market phase? What's its unique spot?
Well, I think the key takeaway is its native integration. Snowflake Cortex brings these LLM capabilities directly into the enterprise data warehouse. If you connect that to the bigger picture, it dramatically cuts down latency. You get AI insights right where your data lives seamlessly, no awkward data shipping. Which leads to, I think, a really fundamental question. How does having AI capabilities in database like that change how companies can actually use their data? What new strategic doors does that open?
Yeah, that's the exciting bit, isn't it? It seems to unlock a level of speed and efficiency that just wasn't really feasible before. Imagine querying sales figures and, in the same breath, asking an AI to predict future trends based on customer review sentiment analyzed right there, or spotting anomalies in security logs and instantly correlating them with database records without moving anything. It's intelligence at the source.
Exactly. It's about making AI operational, truly part of the daily workflow, not some separate, complex project.
What an incredible deep dive this has been. We've gone from understanding these huge, general, pre-trained LLMs all the way to seeing exactly how you can fine-tune them for very specific jobs orchestrated neatly within Snowflake. You've learned step by step how to potentially turn raw data into really tailored AI insights.
Yeah, and knowledge is really only valuable when you can understand it and apply it, right?
Yes.
This whole process shows how powerful and practical AI becomes when it's woven directly into your data workflows. It lets you build these bespoke solutions like that security camera pipeline or a custom chatbot fueled by your own data.
Okay, so here's a final thought for you to chew on. As these AI models keep getting more complex, more capable, How will this ability to seamlessly integrate and fine-tune them within your existing data platform reshape not just single tasks, but maybe entire industries? What new possibilities really open up when building and deploying custom AI becomes almost as straightforward as querying a database?